Okay, Danny, hi. Today we are going to do lesson number 41. This one's going to be super fun, not that long. I think you're really going to like it. I think you're really going to learn something new, so I'm excited to share it with you. Today we're going to practice our multiplication facts, and then we're going to jump into a really fun lesson, okay? Can't wait to see your homework when I get home. Love ya. Bye. Okay, hi there, Danny. Today we are going to go over lesson number 41 for you. And you should have done your multiplication facts by now. And now we are going to go over subtracting across zero and missing factors. And this lesson is super excited, Danny, because I learned some things that I never knew before. So really, you are going to learn some really cool things today, even things that I didn't know until I did this lesson, okay? So the first thing that I'm going to say is I'm a little sorry because I made this lesson a little bit in a hurry because it's like 10 o'clock at night. Well, it's 9:39. It's 9:39 at night. I don't feel all that good right now, and I worked 12 hours today. And now I really want to finish this lesson for you so that you have a lesson tomorrow while I'm at work again. So I'm sorry that this one is a little bit not so good. It doesn't have as cute of animations and stuff, but I'm just going to do my best to make it a good lesson, and I hope that you still like it, okay? So the first thing that we're going to do is some mental math. And we are going to practice adding money that ends in 99 cents, 98 cents, or 95. And remember that when we add 99 cents, this is kind of like adding a dollar and then we're going to subtract a penny. But what if they tell us to add $2.99? Well, that's kind of like adding $3 and then subtract a penny. And the same thing it's going to be is if you're adding 98 cents. So if you're adding 98 cents, add a dollar and subtract 2 cents from that, okay? Or if it's $2.98, add $3 and then subtract 2 cents. And the same thing if we're going to add 95 cents. If you add 95 cents, you're going to add a dollar and then subtract 5 cents. What if they tell you it's going to be $9.95? If you're going to add $9.95, just add $10 and then subtract 5 cents, okay? So I think you can figure these out. Let's go ahead and get started. Number A, or letter A, I should say, is add these numbers, $4.65 plus $2.99, okay? Write your answer. Okay, now we're going to go on to the next one. This is getting really tricky. Let's see if you can add $3.86 plus $1.95. So what I would do, Danny, I'll just maybe help you out on this one. I would add $2 to this in my head. And then whatever answer I get, I'm going to subtract 5 cents or 0.05, okay? So let's see if you can do that and get the right answer. Sorry if I gave you too many hints. On C, we're going to add $6.24 plus $2.98. Let's see if you can do that. You're pretty smart, so I don't want to give away the answer too much. All right, these are a little bit of a review. We're going to do 520 minus 120. And if I go too fast, then just pause the video, okay? E is going to be 350 plus 400 plus 35. Write down your answer. And then F, we're going to do 37 plus 29 plus 220. All right, we're going to go on to problem solving. And problem solving is kind of cool because it says we can quickly add or subtract some numbers on a calendar. So for example, on a calendar like this one, if you pick a number from the middle of the month. So let's say we pick this number. Oh, it doesn't let me write on that. Okay, I'll use a different color. Let's say we pick this number, 11. Now, if you move straight up, you subtract 7. If you move straight down, you're going to add 7, and that makes sense because we're adding 7 days to that number. Now, it says that you can add or subtract 2 other numbers if we decide to move diagonal. So let's say we're going to move diagonally. What numbers, and this is the part that you have to figure out, what number do you add or subtract if you're going to move diagonal? Okay, so it's kind of like let's say you start at the 3. What number do you have to add to that to go to 9 or go to 11? Or you might think about it this way. What if you start at the 20? What number do you need to add or subtract if you go diagonal? In this way or diagonal this way. Okay, so I'll let you figure that out, and I'm going to go on to the new concept. The new concept is subtracting across 0. And the reason I put Kung Fu Panda here, because for one, I know you like him, but also I remembered the part, it made me think of the part where he says, there's now a level 0. So we're going to learn how to subtract across 0. So this is interesting, and this is something really cool that I learned, Danny, because when you do a problem like this, the first thing that we have to do is subtract the ones place, right? So the first thing we would start is subtract. What is 5 minus 6? Now we can't do that. We can't take that away. So we're going to have to borrow. But look at the number next to 5. It's a 0. So we can't borrow against a 0 because there's nothing to borrow. It's got nothing to give. So what we first have to do is we have to go all the way over to the hundreds place and borrow from there. So if we borrow from the 4, we're going to make this a 3, and then we're going to put a 1 here to make this middle number a 10. And now that this is a 10, we can borrow from it. So I'm going to cross out this 10 and make it a 9 and put a 1 here so that we borrow. Okay? So now we can do this problem, and we can do 15 minus 6, and we get a 9. 9 minus 2, and we get a 7. And then in the hundreds place, 3 minus 1, and we get a 2. So it makes sense because now we have, when we borrowed, we basically have 15 in the ones place, 9 in the tens place, because this is like, if it's $405, we have 9 in the tens place, and we have 3 in the hundreds place. Okay, so that kind of makes sense, but it's a lot of steps. So there's another way to think about this, and you can perform this sort of regrouping in just one step if you look at the numbers a little bit differently. And I know that Squidward here looks a little sarcastic when he's saying wow, but I didn't mean it sarcastic. I am actually very impressed. I've never learned how to do this before, how to do it in just one step. I always did it in 2 steps the way I just showed you. But this makes a lot of sense because if you think about the 4 and the 0, if you think about this 4 and the 0, instead of as like hundreds place plus the tens place, you can think about it as 4 $10 bills. Because 4 $10 bills, 4 tens, would make 400 because it's like 40 tens. It's like having the number 40 in the tens place. If this is the ones place and this is 40, but it's in the tens place. Isn't that crazy to think of it as 4 tens? I've never done that before. So if you think about borrowing against 4 tens, what you can do is you can cross this out in one step, and instead of making it 40, make it 39. And then you can put that extra 1 in front of the 5 and make that 15. Isn't that so cool? I never thought about doing it that way. Instead of doing it in 2 steps, you can just do it in 1 step if you think of the 40 as just 4 tens. Wow, I am blown away. My mind is blown away. So then if we do the problem just like we did before, but we do it this new way, this is how we would do it. We would say, well, we're going to start with the ones place and do 5 minus 6, but we can't subtract 6 from 5. So we're going to have to borrow. And then I look over here and notice that that's a 0, and I can't borrow anything against a 0. So now I look at this as one whole number. And what if this one whole number is 40 and I borrow against a 40? And if I borrow from 40, I'm going to make this 39. And then I'm going to put the 1 here for the ones place. And then I can subtract just like before. I'm going to do 15 minus 6, and I'm going to get 9. And then in the tens place, I have a 9 minus a 2, and I'm going to get 7. And then in the hundreds place, I have 3 minus 1, and I'm going to get 2. So I got the same answer, $279, which is the correct answer. I am blown away. I never knew you could do that. It makes it so much easier. Let's do another example and see if it works. Tom had $3 and he spent $1.23. How much money did he have left? So the problem is going to look like this. He started with $3. And then I'm going to subtract $1.23. Okay? So basically what they want you to do is think about, well, let's start at the beginning. The first thing I'm going to do is I noticed that I would do 0 minus 3. And I can't really subtract 0 minus 3 because that doesn't work. I have to borrow. But then I look over here and I don't have anything to borrow right here. So then what if I look at this 30 as a whole? And instead of writing 30, I'm going to change this to 29. And then I'm going to put the 1 right there. So I basically borrowed 1 from the number 30 and I made it 29. And you can do that when there's a 0 right there and you're subtracting across 0. So now I'm going to subtract 10 minus 3 and I'm going to make this 7. And then I'm going to do 9 minus 2 and that's going to be another 7. And then I'm going to do 2 minus 1 and I'm going to make this a 1. And so the answer is $1.77. Now, what they want you to do is they want you to check your answer. Check your answer. And the way that you check it is you do the inverse operation. Instead of subtracting, we are going to add these numbers together. So we're going to add $1.23, and I'm going to move this up so I don't see all that stuff on the bottom yet. We're going to add $1.23 plus $1.77. And if I did the problem right, we should get the amount of money that Tom had originally, which is $3. So let's see if we get it. Let's add 3 plus 7, and we get 10. I'm going to carry the 1. And now we're going to add 2 plus 7, which is 9, plus this extra 1. Don't forget to add the 1. And I'm going to get 10, and I'm going to put a 1 there for 10. And now I'm going to add 1 plus the 1 that I carried. And I end up with $3 for my answer. So I know that I did it correctly because I checked my answer and I got the original $3 back. All right. We're going to go on to the next part of the lesson, which goes over missing factors. And this is not this kind of missing, even though I'm sure that I miss you right now, but this is a different kind of missing factors. So the first thing you need to remember is that numbers that are multiplied are called factors. So since there's a multiplication times table here, numbers that are multiplied, something here times something here, these are called factors. And the answer that you get when you multiply is called a product. Okay, so that's the first thing to remember. Now, if we know one factor and another factor, you can just times them together and you'll get the product. But what if you know one factor and you know the answer of the product? Can you figure out the other factor? And I think you can because you are a smarty pants. So let's try it. We're going to go on to the next page and do example 2. It says, find the missing factors. So these are the things that are missing. So 5n equals 40. What this means is 5 times a number that we don't know is equal to 40. So we have to think about what number do we multiply by 5 to get 40. And if you know your times tables, you'll get it. If you don't know your times tables, you can say, well, what is 40 divided by 5? And if you know division, then you can get it that way. Okay, so because division is the inverse operation of multiplication, so you could figure it out that way. But I know that you know your times tables, so you can figure out that the missing factor here is 8, because 5 times 8 equals 40. So the answer is going to be n is equal to 8. Okay, and that's the missing factor. What about this one? A times 4 equals 36. So this means the same thing. What number can you multiply by 4 to get 36? And since you know your times tables, I know that you can figure out that 9 times 4 equals 36. So that means A must be equal to 9. Okay, so the missing factor is 9. Alrighty, Danny, that is the end of the lesson. Yay! And so now you can go ahead and do your lesson practice and your mixed practice for your homework, okay? Love you, Danny. Can't wait to see what you do with this lesson. Bye.